All right, well, I wanted to go ahead and solve this one for you guys. And so I'll do that. I'm not going to write on it though, so I need to use my writing tool and we'll get through this, but then the video will be up there in the corner, and if you found it, then you found it because it's there in the corner. All right, simplifying radicals. It's still the same thing, and then we can try to combine like terms if we have an exact radicand that matches exactly the same, meaning if we end up with a 3y, then we can add them. If we don't, we can't. Alrighty. I'm going to look at this 12 and realize that's a 4 times a 3. And then because it's a square root, I'm looking for two of a kinds. Boom, we found an exponent of a 2. Y to the third power means I can at least pull out. Let me go over here and explain that real quick. If I have the square root of y to the third power, I can rewrite that as y squared, the square root of y squared times the square root of y. That lets me, I'm using properties of exponents there. If you're like, what magic is this? Right, I'm breaking up y cubed into y squared times y to the power of 1, and properties of exponents lets me do that. Now, properties of radicals lets me split it up, and then the square root of a squared term is just the term itself, or the base, if you want to talk about it like that. So we'd end up with y times the square root of y. That's what's happening down here. So if I were to write this out explicitly, I'd have the square root of 4 times the square root of 3 times the square root of x squared times the square root of y squared, because I'm splitting it up. I'm looking for those perfect squares. Okay, and that's all in my first term. That would end up with a 2 right here. The root 3 would stay root 3. There's no perfect square. That would be an x. That would be a y, and then we'd have our root y. Okay, so that's explicitly what's happening. But eventually, again, this first term would simplify. We like to rearrange it. So this 2 times root 3 times square root of 3 times x times y. We put all the non-radical terms in the front together. So we'd have 2x, y. And then we'd recombine the radical terms. We just put them back. Remember, we have that property, the square root of a times b is the same as the square root of a times the square root of b. Well, that's a 6. We can just put them back together then. If that's true, we'll put the root 3 and the y back together and we'll have root 3y. Hey, look at that. That's actually pretty cool. This one takes another turn. So we simplified this first term. Since we're adding that to 2x, y, root 3y, we have to ask ourselves, can we add this? Are these like terms? Why are they like terms? They are like terms, but here's why. You're like, they're exactly the same. Of course they're like terms. They are, but they're not like terms because they're identical. They're like terms because they have x, y, root 3y. X, y, root 3y. When that happens, the variable part and the radical part, the variable part and the radical part, they're the same. Because they're exactly the same, what is going on? We can add the coefficient together. And then the final answer for this one, 4. X, y, square root of 3y. All that is saying is these are just different equivalent forms using the rules of mathematics so that when we're done, we kind of cleaned it up. But that 4 times x times y times the square root of 3 times y will be the same as everything else you see on the board. Okay? Let's see what about down here. Is this accurate? Can we show it? Is it true? Well, let's just take a look really quick. I'm going to be able to take out an x squared. Because see, there's 2 x squareds in there. X to the 4th is x squared times x squared. So this one will become 6x squared root 2. Oh, it's multiplication. We like multiplication. It's a little bit more friendly. All right, let's see this. Oh, remember we did it with that. That's going to become 2 root 3. This 12 will be 4 times 3, so we'd have 2 times the square root. Hold on. I actually am going to pull out this y squared because I noticed that can come out front, so I'm going to go ahead and pull that out right now. Remember, we're going to multiply. So I took this square root of 4 times the square root of 3, and I see there's a perfect square with that y variable, so I'm going to pull that out. But I need to leave what was left. What's left is going to be that x. There's no matching. There's no squared. It has to stay. And then the 3, because the square root of 3 is not perfect. Okay, so now I'm left with that underneath, but we're multiplying everything together. So multiplication is commutative, which means order doesn't matter. Or it's associative, which means you could regroup it. You could regroup the multiplication in a friendlier way. I'm going to look at the whole numbers first. So we have 6 times 2, because that's outside of the radical, 12. There's an x squared outside of the radical. There's no other x's, so I'm just going to leave it x squared. There's a y outside the radical, so I'm going to leave that. Remember, we like to pull them out front. So far, so good. And then finally, we have a root 2 and a square root 3x. Square root and root right now mean the same thing. Let me just write it right next to each other. The square root of 2 times the square root of 3x. But properties of radicals say that's the same thing as if I just multiply what's underneath the radical, if I just multiply the radicands together. So finally, we'd have 2 times 3x, which would indeed get us back to 6x. All right, thanks for watching. I realize I like to provide you guys solutions to these Nearpods. That way, if you want to try that extra problem, get that extra thinking, you can check your thinking. Maybe you did it a different way. Love that. Keep it coming. Try it a different way. Just make sure you follow those rules of mathematics because it keeps things equivalent. And that's the reason we have them. We haven't proved them. You just accept that that's true. You can always explore the idea of proving it yourself if you want to. All right, thanks for watching. Yep, that always is bye math work.